Hello. All right, so if you can turn to page 7 of your Unit 2 packet, today we're going to talk about graphs of polynomial functions. Now on this page, we're going to take a look at 3 specific graphs: a quadratic, a cubic, and a quartic. Okay, a quadratic. A quadratic is just a polynomial of degree 2, which means that its biggest exponent is going to be a 2. So for example, if we were to graph y equals x squared, this would be a second degree equation, okay? Its biggest exponent is a 2. And I mean, you could have other things. It could be y equals x squared plus 3x minus 4. You could have other terms after this, but the degree just talks about the biggest exponent, okay? Now, a cubic is a polynomial of degree 3. So you would have y equals x cubed, x to the third power. And again, you could have other terms after this, but if we're just looking at the biggest exponent, okay, that's going to tell us the degree of the function. And then a quartic is a polynomial of degree 4. So y equals x to the 4th. And again, if you had other terms after it, right, as long as the exponents were smaller, like if you had y equals x to the 4th plus 2x cubed plus 3x squared minus 4x minus 1, as long as your biggest exponent is a 4, we would call that a polynomial of degree 4. Now, by looking at a graph, I'm going to keep it simple for now. It's going to get more involved as you progress in math, but if you were looking at, let's say this first one, the quadratic, see how this is going down and then up, right? It has 2 directions. It's going down and then it's going back up. Okay, if there's 2 directions, down, up, or it could also go up, down, that's going to be a second degree polynomial. Whereas if you take a look at this one, see how it's going up, down, up? Okay, so it's going up, then it's going down, and then it's going back up. Okay, this has 3 directions, so the degree is 3. And if we look at this one, this has 4 directions, right? Down, up, up. So again, down, let me get my pen, down, up, Okay, there's 4 directions, so it's going to be a 4th degree polynomial. All right, so if you turn to the next page has a couple definitions here: roots, zeros, and solutions. Okay, all 3 of these terms refer to the x values at which the function intersects the x-axis. All right, so take a look at number 13. Here's our x-axis. All right, we could see that this function intersects the x-axis right here at -2, right here at 0, and right here at 3. Okay, so these are the 3 x values at which our graph intersects the x-axis. So these right here, -2, 0, and 3, those are called our roots, our zeros, as well as our solutions. So when this question says, which set lists all the roots of when our function f of x equals 0, well, these right here are our roots. Okay, so we see that in choice 3, -2, 0, and 3. And instead of writing them out, you could put them in curly brackets like they do here. Okay, so choice 4, I'm going to cross that off, would be our answer. All right, so let's take a look at the next one. The graph of h of x is shown below. So they want us to determine the roots. So again, the roots are where the graph crosses the x-axis. So we could see we have a root at -1, at +2, and at +3. Okay, so we could either list them out, like I did right here, or if you prefer, you just put them in curly brackets. And if you put them in curly brackets, you list them in order, in ascending order, okay, from least to greatest. So right like that. Okay, now, letter B, determine the factors of h of x. So if you recall from solving equations, don't factors and solutions have opposite signs? So if we have a solution of x equals -1, its corresponding factor would be x plus 1. So we put in parentheses x plus 1. All right, just like if we have a 0 or a root or a solution of x equals positive 2, the factor in a parenthesis would be x minus 2. And then same thing right here. The factor that corresponds with x equals positive 3 would be x minus 3. Okay, now one thing I want to show you is if you go to y equals in your calculator and type in those factors, right, x plus 1 times x minus 2 times x minus 3, and if we hit graph, what you'll notice is that, well, let me see if I can move this. Look at this. Oh, there we go. See this? Our graph here matches up with our graph here. All right, now if we take a look at number 15 on the next page, it says determine the zeros of the polynomial function. Now, if I saw something like that, I mean, the first thing I would do is to determine the zeros is I would probably set this equal to 0 and try to factor. But when I do, watch what happens. Here, I can pull out an x squared, which leaves me with x plus 2. And here, the only thing I could pull out is maybe like the negative sign, right? Negative 1. And when I do, it leaves me with positive 11x plus 12, okay? So these don't match. So unfortunately, I'm not able to do this by hand, by factoring. So let me erase this. So we need to come up with a plan B. So if I want to find my zeros, well, all I have to do is go to y equals in my calculator and graph this. Okay, so I went to y equals and plugged that in, and when I hit graph, here we have it. Now, we can see that it looks like here it intersects the x-axis at -4, -1, and positive 3. But even if it's hard to tell by looking at it, you can go to your table of values, right? If you hit second graph, you can go to your table of values, and what we're looking for is where the y values equal 0. So let me scroll up a little. I'm going to scroll up, and we could see, first of all, this is a third degree function, so we should have 3 solutions. And look here, they are at -4, -1, and positive 3, just like the graph showed. Okay, so I know you're supposed to be keeping notes in your packet as you watch this, so just so you have some notes to follow off of, if we wanted to sketch a picture of the graph, okay, I'm just going to go back to my calculator, and it looked something like this. It's not the best picture, but we could see that we have a solution right here at -4. We had one right here at -1, and we had one right here at positive 3. Okay, so our zeros, I'm going to use curly brackets again, would be at -4, -1, and positive 3. Make that 4 a little better. There we go. If you prefer to show in your notes that we go to the table of values, right, where we see the x and the y in our calculator, we know that these y values were equal to 0 when x was equal to -4, -1, and positive 3. But let me box this off. This is the final answer, okay? Those are our zeros. Now in part B, it says to determine the factors. Now remember, the factors have the opposite signs of the zeros. Okay, sorry, I just fixed that -4 that was a little sloppy. So if we have a 0 at x equals -4, we know the factor is going to be x plus 4. Okay, and then if we have a 0 at x equals -1, the factor will be x plus 1. Please make sure you write your factors next to each other. All right, and then our final factor, if we have a 0 at x equals positive 3, what factor would correspond with that? X minus 3. Okay, so factors have the opposite signs of the zeros or the solutions. Again, the zeros, the roots, and the solutions are where the graph crosses or touches, basically intersects the x-axis, and then our factors have the opposite signs. Okay, so for the 3 examples at the bottom of the page, I mean, they all want to know which is either not a factor or which is a factor. If you had tried to, let's just say in 16, tried to factor this by grouping, you would run into a dead end. The parentheses wouldn't match. So no big deal. Let's do it like we did the last one. Let's go to y equals in our calculator and let's graph this. Okay, so y equals, I plugged it in, and when I hit graph, we can see that the zeros are at -1, +3, and +8. Okay, so I'm just going to sketch this out. So we have a 0 at x equals -1, a 0 at x equals +3, and another one at x equals +8. All right, so since we know that the factors have the opposite sign, we know the factors are going to be at x plus 1, x minus 3, and x minus 8. Okay, so the only one that's not a factor is choice 2, x plus 6. Okay, and just a reminder, if it's easier for you to hit second graph and go to the table of values, right, you could see that we have a 0 at, when x is -1, y is 0. When x is 3, y is 0. And if we keep scrolling, when x is 8, y is 0. So again, -1, +3, and +8 are a 0. So the factors have the opposite signs. All right, so for number 17, I just kind of jumped right to it. In the calculator, I graphed it. This is what it looks like. And then I also went to the table of values, and this is what I see. So look at the answer choices and see if you could determine which of the following is, again, not a factor. All right, so we see we have a 0 at -2, which, look, that clarified it. We have a 0 right here at +6, and we have another 0 right here at x equals +7. Okay, so we know the factor that corresponds with a 0 of -2 would be x plus 2, so that's not our answer. We know a 0 that corresponds with, a factor that corresponds with a 0 of x equals +6 would be x minus 6, so that's not our answer. And then a factor that corresponds with a 0 of x equals +7 would be x minus 7. All right, so it looks like choice 2 is our answer. Okay, so for number 18, I went to y equals, and I plugged in this and hit graph, and this is what I see. Now, it kind of looks like maybe there's a 0 at +1 and +2, but look, this one kind of looks like it's missing it a little. It doesn't look like it's a little bit, the 0 is a little bit to the right of 1. So if you go to your table of values, look at that. There, at 1, there is not a 0. At 2, there's a 0. So really our only 0 here is at x equals +2. So if we have a 0 at x equals +2, doesn't that mean that our factor has to have the opposite sign? So which of these shows the correct factor? Yep, choice 1, x minus 2.